morning, class. I know this is an unusual way to do geometry. Hopefully it won't be something we have to do repeatedly. Hopefully it's just a one-time thing. I would say raise your hand if you're here. This is the most awkward way of teaching to me when I don't have you in front of me. I thrive on interacting with each one of you face to face. So we're going to open in prayer, and then I'm going to go ahead and review some of last week, kind of go over some basics about the test that I'm going to be sending to you on the area and the volume. And then from there, I'll give you a few extra pages to do this week with some new topics. So I'm going to go ahead and pray, and then we'll get started. Dear Heavenly Father, I thank you so much for this day and for your many blessings. Father, I pray that as we're in this unusual circumstance of having to do this class through a video lecture, I pray that you would help me to speak clearly, to teach clearly, and that the students would be able to understand. Father, I pray for each one and what they may be going through right now in their lives. We thank you for your the many blessings that you've poured out on us. We praise you and exalt you because you are God and you are in control and you love us. So Father, I pray for each one this week that they'll have a wonderful week and we'll be able to get back together next Wednesday. In Jesus' name, amen. Okay, so yes, next Wednesday we do plan on resuming class as usual. I'll send the link to this video. Obviously you have the link to this video, or you wouldn't be watching it, but you'll also have your homework assignments that I expect you to have completed to bring in. If you have any questions, feel free to contact me and I'll be glad to try to help you work through things. So I want to go back, before we review a little bit on the area and volume, I want to go back and review some of our definitions from last week. Be sure that you know your definitions, and I noticed I forgot to put there we go, addition postulate. I do want to make sure that you know this vocabulary because you will have a quiz on this when we return, okay? So the new vocabulary from last week, the first one was the adjacent angle. And if you remember, adjacent angles are two angles that share a ray and a vertex. So they have to be connected at the hip, okay? So you might have two angles like this. And because they share the center ray and they share this vertex, they're adjacent. Any angles, this angle, although they're connected and they share a same ray, they do not share the same vertex. So that would not be an adjacent angle. So make sure that you study the definition for adjacent angles. The angle addition postulate basically tells me I have three angles here. Notice this is an adjacent angle. And how do I have three? Well, I have one here, I have one here, and I have one here. And the angle addition postulate basically tells me that if I add the measure of this angle, let's call this angle X, and let's call this Y, just so that you can see it. And let's call this, well, let's just rename that because technically it can't be X and Y since it's split. So let's do A, B, C, and D. So let's say that A, B, and D, let's say that let's say it's a 25-degree angle. And let's say that D, B, C, let's say that it's a 30-degree angle. If we add these two together, we will be able to determine the measure of the big angle, ABC. So angle ABC equals 25 plus 30, which would be 55 degrees, okay? Now, say that you were not given this information, but you were told that this big angle was 55, and you're told that that's 30. And in this situation, all you'd have to do to solve the missing angle here is to do 55 minus 30, and that would then give you the measure of the angle, which would be 25. Okay, this is a review. I know if you were not in class last week, this is new to you, so you can follow along in your book with this. So that's your angle addition postulate. Complementary angles. Remember, I will compliment you if you are right. Well, a right angle is one that adds up to be 90 degrees. But complementary angles are any two angles that would add up to 90 degrees. So that would be, you can have two angles here. So you might have one that's 50 and you might have one that's 40. They do not have to be adjacent. They don't have to be connected at the hip. They can be adjacent, but they don't have to be. It's any two angles that add up to 90. And when you are right, they add up to 90 degrees. When you are right, I will compliment you. So maybe that'll help you remember complementary. So the other one, if you remember complementary, then supplementary should be pretty easy to remember. Supplementary are any two angles that add up together to give me 180. So let's say that we said this one was 110, and this is not a good drawing. This would have to be bigger, but I'm just telling you. And let's say that this was 70. These two angles do not have to be adjacent, but they do have to add up to 180, okay? Now we do have something that is supplementary, but also adds up to 180, and we call that a linear pair. And let me explain that. We have a line, and we have two angles sitting on a line. We call that a linear pair. Linear pairs always add up to 180. So although linear pairs are supplementary, they are special in that they are the two angles sitting on a line. So what does that mean? The linear pairs are adjacent. A linear pair has to be adjacent, has to connect at the hip, okay? So that's your difference between a linear pair and supplementary angles. Let's talk about, I know I'm running through this pretty fast, but this should be review. Let's talk about the vertical angle theorem. First of all, we need to know what a vertical angle is. So if I had A, B, and C, and D, and E, I would say that angle ABC, this right here, is vertical angle to DBE. So they are right across from one another, okay? Also, vertical angles are always equal to each other. So this angle equals this angle. Another vertical angle in this drawing would be right here and here, right across from each other. So vertical angles are always opposite one another involving intersecting lines, okay? Now, just remember, keep that in mind, and I would probably put a note as you write down your words that complementary adds up to 90, supplementary 180, linear pair adds up to 180. Vertical angles don't add up to 180, they're equal to each other, okay? All right, next thing, talking about a transversal. A transversal, just in simple terms, is a line that cuts through or bisects a set of parallel lines, okay? Now for what I'm going to teach, these lines today, these lines have to be parallel to ring true for the things I'm going to be teaching today, okay? So that's your transversal right here is this line, okay? Here's your parallel lines. Notice they're marked with the little arrows, okay? Now, let's go ahead and talk about what types of different angles, just to review here. If I label this 1, 2, 3, 4, 5, 6, 7, 8. I want to talk about what a corresponding angle is. Remember last week I told you that I like to view this as two pieces of bread. This is a sandwich here. This would be the inside of the sandwich. This would be the outside of the sandwich. And if I have an angle sitting on the top piece of bread, he's on top of the top piece, and this one would be on the top of the bottom piece of the bread. Those would be corresponding angles, okay? Corresponding angles, go ahead and put a note, they always equal each other if they're truly corresponding. So the measure of angle 1 would equal the measure of angle 5, and that's a corresponding angle. Another corresponding angle would be this 3 sits on the bottom of the top piece of bread. This 7 sits on the bottom of the bottom piece of bread. Those angles are also corresponding. Same with 2 and 6, they're corresponding, and 4 and 8, okay? So those are your corresponding angles, and they equal one another, okay? The next one would be the consecutive angle, and I like to say that, as I said last week, it helps me to remember that con men like to hide. So the consecutive angles, con for consecutive, the con likes to hide with inside the sandwich, okay? So they have to be on the same side of the transversal. So 3 and 5 are both hiding within the sandwich. That would be a consecutive angle. The other consecutive angle would be 4 and 6. Now something to keep in mind with consecutive angles is that consecutive angles add up to 180. So the measure of angle 3 plus the measure of angle 5 will equal 180. The measure of angle 4 plus the measure of angle 6 will equal 180. Now, remember we said that a linear pair also adds up to 180. So if it helps you, you can think, today I'm going to align up to pick out the con man, okay? Those two things, the consecutive and the line for linear pair, both add up to 180. They have that in common, okay? The other ones are just simply going to equal one another. 1 and 5, 3 and 7 is corresponding, 2 and 6, and 4 and 8. Now, moving on, let's talk about alternate interior angles. Well, alternate, if you are tying your alternate shoe or you're standing on your alternate foot and you switch, that means basically to alternate. So if we're looking at alternate sides of the transversal, we're looking at one angle being on one side of the transversal and one angle being on the other side of the transversal. So alternate interior tells me it's going to be inside the sandwich, and they're going to be on opposite sides of the transversal. So in this example, 3 is inside the sandwich, and I go to the other side of the transversal down here, and there's 6. So 3 and 6 are alternate interior. 4 and 5 are alternate interior. Alternate interior angles are also equal to each other. Okay? Now you might say, why are 3 and 4 not alternate interior? Because they are on opposite sides. But 3 and 4 is actually an upside down linear pair. There's your line, there's your pair of angles. Okay? Same with 5 and 6. They're on alternate sides and they're inside the sandwich. But 5 and 6 is a pair of angles sitting on a line. There's our linear pair. Okay? So alternate interior are equal to each other. The next one would be alternate exterior. Well, if alternate interior inside the sandwich, the alternate exterior would be outside. So I'm outside of the sandwich here, and I want to find the angle that's outside the sandwich on the other side of the transversal. And there it is, it's 8. So 1 and 8, and 2 and 7. Alternate exterior angles are also equal to one another. Again, pointing this out, 1 and 2 are both outside of the sandwich. However, they are a linear pair. They're they're a pair of angles sitting on a line. Okay? So everything is equal to one another except for the linear pair and the consecutive angles. The con man in the lineup, they're equal to 180. Now looking here, we also can see that we have a vertical angle here. We have 1 and 4. They're across from these intersecting lines. They're angles across from each other. So 1 and 4 are vertical angles. They're equal to each other. 2 and 3 are vertical angles. 5 and 8 and 6 and 7 are vertical angles. All right? So this was should have been a very quick review. For most of you were there last week. For those of you that were not able to be there, follow along on your book. If you have any questions, be sure and contact me about that. Okay? So let's move on today with the new topics, and then we'll come back and review some for what you need to expect for your test that I will send you. Okay? I may also send you a couple more handouts on practicing these. These are not something that we learn and forget. You will use these again as you start doing proofs. You need to be able to understand what all of these are and to be able to remember them, because they're going to remain with us through the course, okay? So practicing is a good thing. You're doing a few more problems. So if you will turn to me with me in your books, you should have completed up through 112. And then we turn over to what would be 113. It's not numbered in your book, I know that. But it says that logic problems with parallel lines cut by transversals. And you can go back and read the paragraphs, but just to kind of boil it down and make it simple for you, need to understand that in order for angles to be consecutive angles, corresponding angles, alternate interior angles, any of those, in order for those to be alternate exterior, the lines have to be parallel. If those lines are not parallel, then there's no way that those angles can be equal to one another or add up to be the 180 in the case of the consecutive angle. Okay? So I want you to look at that example there, the first one. We see that AB is parallel to CD. We know that because it's marked with the little arrows. So we know that 1 and 2, they would be equal to one another. They're alternate interior angles, and they're equal to one another because the lines are parallel. So it's kind of thinking backwards a little bit. Look at the one beside it, the example there. Now we can look at that and our eyes tell us that those lines are not parallel, okay? So because they are not parallel, 1 and 2, even though they're alternate interior angles, they cannot be equal to one another because the lines are not parallel. So let's think of that backwards a little bit. Down at the bottom, there's a couple of examples there too. And it says that we want to know, it says in the figure below, we want to know if measure of angle 1 equals the measure of angle 2. And is AB parallel to CD? And we can say that 1 and 2 are corresponding angles. If they are corresponding angles, if they're corresponding, then, thinking backwards, if they are corresponding angles, then the lines are parallel, okay? But look at the one beside it. I do see that we have alternate exterior angles, but look at what it's asking in the example 2 at the top. Must AB be parallel with CD? Must it be? Well, it may not be, because even though we see that 1 and 2 are alternate exterior angles, we don't know that those lines are actually parallel. So this is kind of twisting a little bit and making you think backwards, kind of thinking a little bit more logically about this. Let's do a couple examples so that you'll know what I'm talking about. If we go over to 114, well, there's another example up there, example 3. In the figure below, which pair of angles must be equal to show that AB and CD are parallel? We need to explain it. So let's look at 1 and 4. Those are vertical angles. Do vertical angles have to be equal to one another to prove that it's parallel? Well, not necessarily, because as you're looking at 1 and 4, you're just dealing with one line segment there, AB, okay? Look at 5 and 6. 5 and 6 is a linear pair. Well, do those have to be equal to one another? Well, first of all, a linear pair is going to add up to 180. So we can just scratch that off. Look at C, 7 and 3. Well, it looks like to me that those are corresponding angles because 3 sits on the bottom and 7 sits on the bottom of the bottom piece of bread, the bottom of the top and the bottom of the bottom. If those are true, or if those are equal to one another, that's what it's asking. If these angles are equal to one another, would it show that AB is parallel to CD? And yes, it would. We don't have to go any further. So that would be your answer, would be C. Okay. They give another example in example 4. In the figure below, which pair of angles must be equal to show that AB is parallel to CD? Same type of question here. Okay. So let's look at A. That'd be 1 and 7. Okay. 1 and 7. Well, on this particular one, I have the 1 sitting on the top of the piece of bread, and I have the 7 sitting on the bottom. Be careful. In order for those to be corresponding angles, the 1 would have to be on the top, and then the 5 would be on the top. Those would be corresponding angles. So 1 and 7 are not corresponding. Be careful with that. 5 and 6. Well, we're dealing with a linear pair. A linear pair, they're not going to be equal to one another. And that's also not including the line AB. So we can throw that one out. Okay. Look at 7 and 6. 7 and 6, we have vertical angles. We know that vertical angles are equal to one another. However, that only involves line CD. So we don't have to have that information to be equal to each other for those lines to be parallel. So we can throw that one out. So the only one left is D, and let's talk about why that works. We have 5 and 4. If you look at angle 5, he's inside the sandwich on one side of the transversal, and the 4 is on the other side of the transversal, also inside the sandwich. And so that would be an alternate interior angle. And if the alternate interior angles are equal to one another, if they are, then the lines are parallel. Okay? So that's how you'll do those. And then it says in your assignment, for these, read each question, mark T for true and F for false, and then explain your answer. So make sure that you don't just go through and mark true, false. Tell why, write why. So let's do the first one together. It asks us, measure of angle 1 equals measure of angle 2. Does it? Does it equal? Do those equal each other? Well, I can see there measure of angle 1 on number 1 that they marked A, B, and CD with the little arrow. So I know that those lines are parallel. That's helpful to me. So really pay attention to what the information they're giving you. I also see that 1 sits on the bottom of the top piece of bread and 2 sits on the bottom of the bottom piece of bread. So yes, these would be corresponding angles. So I would then tell my reason, I would write my reasoning as this. AB is parallel to CD because the measure of angle 1 and the measure of angle 2 are corresponding. That means that the measure of angle 1 equals the measure of angle 2. So you're going back and restating what it told you in the given information at the top. They're asking you, are those two angles equal to one another? And you're able to prove that they are. So this is beginning of getting you thinking about proofs, but we're not quite ready to plug them into proofs yet, okay? That kind of gets you in that thought process. So you'll go ahead and complete those pages up through 116, and then I want to introduce a triangle sum theorem to you, okay? I'm going to go ahead and write this. Triangle sum theorem. And anytime that you see the word sum, you should think addition, okay? And anytime you see the word triangle, it means we're going to be dealing with triangles, okay? You're not going to use a triangle sum theorem with a square. So just keep this in mind that we're going to use it with triangles. Now, this theorem tells me that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. In other words, you already know that triangles add up to 180, and what that's telling you is that each of the angles added together will add up to that 180. So if I had an angle here, and let's say that I had this as x, and if I had this as x, notice with this would have to be an isosceles triangle to have those two together. And let's say that I said that this was 35, okay? And I'm going to label this as 1, 2, 3, just so you can see it. They won't always be labeled 1, 2, 3, but a triangle has 3 angles. So basically what it's telling me, if I add these 3 angles together to get 180, so I would do 35 plus x equals 180, okay? Now I would combine what matches 2x plus 35 equals 180. Now this particular one, we have the bridge here in the middle, and the 2x wants to kick the 35 away. Does not like the 35, so we're going to kick him to the other side of the bridge, and he will become negative. So we're going to subtract that, and we get 45. Now in this situation, when we divide, we're not going to get an exact answer because 2 doesn't go into 45 evenly. So then you would do your division problem of 2 into 45. 2 goes into 4 2 times, and then 2 goes into 5 2 times. And so let's add a 0 and bring it down. 2 goes into, let's put our decimal there, bring it up. 2 goes into 10 5 times, so your answer would be the 22.5. Okay? So these would each be equal to 22.5. So that is the basics of your triangle sum theorem. So let's look at these examples here on page 117. At the top, it's labeled 81, 73, 26. All of those angles should add up to 180. All right? There's the theorem there written for you. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. A couple of reminders from the section on the basics. An equilateral triangle, just like I just did an isosceles triangle here. An equilateral triangle, all 3 sides are going to be equal and all the angles are going to be equal. So you see there, you're not given any measurements, but you have 3 x's. So you would add your x's together, 1x, 2x, 3x equals 180, and divide, and you would know that every single one of those angles would be 60 degrees. Looking at example 2, we have an equilateral, okay? So we have 2x minus 12. Now, one angle equals, from an equilateral triangle equals 60. So you would put that to 2x minus 12 equals 60. And then bring your 12 over, and you see where it's solved there. I'm not working this one because you can see it. I'm going to work another one on the board. And you find out that the angle is 36. If this is an equilateral triangle, then x will be 36, all the way. But all the angles are going to add up to 160. So you're just solving for x on this situation. We want to know what x is. If you plug in 36 for x, 2 times 36, and you subtract 12, you should get the 60, working backwards. Okay? An isosceles triangle, just a review of that, you have 2 sides that are equal to one another, and the bottom angles are equal to one another. So in this situation, you have 30 at the top, and you have x and x at the bottom, kind of like what I did here, but I did 35, and it didn't come out even. If it was 30 at the top, it would have come out even to be 75. The example beside it, example 4, Remember, these two angles in an isosceles triangle are equal to one another. So you would write 2x minus 27 equals x plus 53. Identify that as isosceles triangle. Transpose, move your x's to be together, your numbers to be together, and you will find that x is 80. So let's work a couple of these together. All right, let's do number one. We want to find the missing angle. So I'm going to leave this up here so that you can remember, and I'm going to use the same triangle. Now in this situation, this is not an isosceles. Okay, 24, and then we have, that's not 240, it's a degree sign, 88 and x. So I want to solve for the missing angle. So what I'm going to do is I'm going to do x plus 24 plus 88 equals 180. Okay? When I add these two together, I get x plus 112 equals 180. Now to get my variable alone, the x does not like the 112. We're going to kick him to the other side of the bridge, and he'll become negative when we do that. So, whoops. So we find out that x equals 68 degrees in this particular problem. Okay? All right, moving right along then, I want to do one that has, well, let's do number 30. Why not? This will be on page 121. Erase this. And in this particular situation, my triangle will not look exactly like the one in there, but I have this labeled as x plus 21. I have this one as x plus 23. And this one I have x plus 61. I do want to point out to you, they're asking you to identify the triangle sum theorem all the time. They're wanting you to write that on every problem that you're using. I know that's repetitive and redundant, but they're wanting you to associate triangle sum theorem with this. You can abbreviate triangle sum theorem to TST. That's fine, so you don't have to write that out every time. TST, I know exactly what you're talking about, triangle sum theorem. Now, if we're going to apply this theorem, this angle plus this angle plus this angle is going to add up to 180. So, x plus 21 plus x plus 23 plus x plus 61 equals 180. Let's combine our like terms. I have 1, 2, 3 x's, and just to save my brain on the math here, all of this adds up to 105. 21 plus 23 plus 61 is 105 equals 180. Remember, my 3x does not like the 105, so we're going to kick him to the other side of the bridge and he'll become negative. Okay, and I will find out that 3x equals 3. I need to divide now. This means multiplication. Do the opposite function and divide. So x equals 3. Not 3, sorry. 10. Okay? Caught that right as I was writing it. So that's how you do the triangle sum theorem. So I do want you to go ahead and add that to your assignments. You're going to go ahead and complete through page 122. I'm going to send you the test, and I got one more theorem I want to introduce to you, and this will finish up the book. Okay? So next time we meet, I'll have new books for you. Don't ever get rid of your old books. Hold on to them because they'll help you out in studying, like for future SATs, ACTs, things like that. Both of those tests are pretty heavy in geometry, and a lot of the things that we've covered you will see again. Okay, so the next one that I want to cover is called the remote exterior angle theorem. One of the things when I'm looking at this theorem, I want to identify some words here. First of all, I see remote. When you think of something being remote, you think of it kind of being out there by itself. So remember, remote's going to be alone, he's all alone. And exterior, if you hear the word exterior, you're thinking he's on the outside. So he's remote, he's on the outside, poor thing, right? So the remote exterior angle theorem, keep that in mind. So what I have here is I have a triangle. And here, everybody within this triangle, they're pretty happy, they're all together, okay? And I have 1, 2, there's my angle measurements. We're going to call this one on the outside 3. Now 3, the measure of angle 3, he's remote. He's outside of the triangle, and he's all alone. So he's exterior, outside, and he's alone sitting out here, okay? The remote exterior angle theorem tells me that the measure of angle 1 plus the measure of angle 2, this one, equals the measure of angle 3. Do not get mixed up and label this as 3 on the inside. The 3 is the remote one, the one that's out there by himself. So you're going to be adding the two angles that are actually opposite it to find out what that measure is. All right, so kind of looking at a simple one, let's say that we had this labeled as 41, and we have this labeled as 87. Okay. All right. Now there's a couple things that I can do here. I want to show you how I can plug this in to find it using the remote exterior angle theorem. So first of all, using this theorem, 41 plus 87 is going to equal this. Okay. So if I add that together, I get 128. So the measure of angle 3 is 128, or 128 equals the measure of angle 3. Now, one of the things that I want to also show you with this is you might have said, wow, I see this 3 sitting here, and there's a line and a pair of angles. So since there's a pair of angles there, I know that this would be a linear pair sitting on a line. If there was some way I could find out this angle, then I could easily find out this angle. So when you're using the remote exterior angle theorem, this was a lot quicker for this. But I want to show you can also use the triangle sum theorem. And the way that we can do this, we don't know what this angle is, so let's make that x. So we would do 41 plus 87 plus x equals 180. Remember the triangle sum theorem? Measure of angle 1 plus measure of angle 2 plus the measure of angle 3 adds up to 180. Okay? So I get 128 plus x equals 180. Combine those together. The x is going to kick the 128 to the other side of the bridge to subtract, and I get 52. So x equals 52. Now, if I know that this is 52, which I just figured out it was, I can figure out the measure of angle 3 because I can say there's a linear pair, and I know that this angle plus this angle equals 180. So 52 plus the measure of angle 3. Make sure you don't write this as 3 degrees. This is the angle name, okay? So 52 plus the measure of angle 3 equals 180. Okay. I'm going to go ahead and kick the 52 over here and subtract it. Okay, and I'm going to get 128, it's the measure of angle 3. Now, isn't this interesting? That's what we got, and that's what we should get when we use the remote exterior angle theorem. When you use the triangle sum theorem, you get the same answer, and you should. The angles don't change. But it's kind of neat how you can see plugging in the different theorems work, all right? But for this particular assignment, I want you to be using the remote exterior angle theorem. We'll do one of these together, and then let me see which one I want to do. Okay, let's go ahead and look at number 20. All right, it'll be on page 127. Looking at number 20, and I'm going to leave this theorem up here for you so you can see it, because this is new to you. And I'm going to go ahead and draw this wonderful angle here. Again, this is not art class. One thing I noticed, there's 2 hash marks. So what that tells me is that these 2 sides are equal to one another. And I know that a triangle that has 2 equal sides is an isosceles triangle. Okay? And it tells me here that I've got x plus 34. And then this angle out here is 3x. Okay? Now, since this is isosceles and this is x plus, I wrote 35, I'm sorry, it's 34. I would alter our answer a little bit. So x plus 34, I also know that this angle is x plus 34 because it's isosceles. Now I can add these two together. X plus 34 plus x plus 34 equals 3x. All right, let's combine things on the side of the bridge before we start moving anything around. And so I'm going to combine my x's. I have 2 of them here, so that's 2x. And 34 plus 34 is 68. And I have that equal to 3x. Now, my 3x is hanging out here. He's lonely. This 2x would like to join him. Make sure you don't move the 68 because then you have the 68 hang out with the 3x. The 68 wants to be alone and the variables want to be alone. So we're going to move the 2x over here. And he's positive, so he crosses the bridge and becomes negative. And we get 68 equals x. Okay? So that is your answer. If I were to ask you to tell me what the measures of them are, you do not have to do this on this assignment. But if I wanted to know exactly what this measurement was, you would plug in this number to figure it out, okay? Wherever you see an X. So there we go. All right, remote exterior. These theorems are kind of fun, and that should take you to the end of the book. So let's just briefly I wanted to point out a couple things with the area formulas and things. When you do your area test, which I will send home with you, your area and volume test, you will not have to do any of the complex shapes where you're having a cylinder on top of a rectangular prism or anything like that, okay? You're just going to do the basic things on here. But there will be a couple of those harder ones as a bonus. You do need to know how to solve for total surface area, and you need to know the difference between lateral surface area and total surface area. So you'll want to look those up before you take your test. Also, all of the formulas are on the test. It is matching, but they are all there. Remember that your rectangle and your parallelogram have the same formula. So you will use that answer twice, okay? So just keep that in mind, you know, as you're going through and you say, oh, I already used that, I can't use it again. Well, there are the rectangle and parallelogram. Remember, the parallelogram is like a drunk rectangle. He's kind of leaning to the side, okay? They share the same formula for the area, okay? I did want to point out a couple things I just want to remind you of. That when you see this little symbol, it almost looks like you would mark a right triangle, but it also kind of looks like a chair. And when you see this little symbol, it is reminding you that that is your height, okay? So for example, let's say that I had a triangle, and you were going to use the formula of base times height and divide it by 2, okay? So that would be my area for my triangle. But you're trying to figure out what the base is. Is this the base? Is this the base? Is this the base? Well, I'm going to go ahead and put this here. So you know what? If you see that there, this is your base. This triangle is sitting upside down. So this is the base of your triangle. Okay, there's your base, and the height would be going that way. Okay? Remember that with your basic shapes, you don't use the slants as your heights. Now, some of those more advanced shapes, you do use the slant, and that the symbol of that is L, okay? Symbol for perimeter is P. Apothem, which is like a radius, is an A, okay? So the only one that's a little bit different is the L for the slant. But anyway, for all of the ones on the test, other than the bonuses, you're going to use the height, like of a triangle is going to go this way. The height of a pyramid is going to be, if you were inside a pyramid and you want to hang a chandelier, you hang it from the middle and it hangs straight down. Okay, so you're going to go up the middle, not the sides. So I just wanted to point that out to you. So be careful when you're doing your test that you're not saying, oh, here's the base, and this right here would be the height, you know, measuring the height. Make sure that you see if that triangle happens to be upside down. Because in the past, I've had students mix that up and get the problem wrong. They didn't do the math wrong, they just didn't recognize where the base of the triangle was. And that's a big deal, you have to know that. Okay? All right. Well, I'm going to go ahead and wrap up then. So you're going to review all of your formulas. They'll be on the test, they'll be matching. You're going to go back and review all of the vocabulary and the vocabulary that I gave today, the triangle sum theorem and the remote exterior angle theorem. You're going to finish the book. Go ahead and complete it. When we meet next week, we'll review all of this. I'll give you your new book, and we will get right back on track. If you have any questions about plugging in the formulas with these shapes, be sure and ask me. Don't hesitate to contact me, and I'll help you see how to plug those in. I do want to point out one more thing. And this would be your... I'm going to find an example in here. I may just do my own. What do they have? Okay. I'll just make one of my own. But I wanted to point it out to you. Let's talk about the rhombus for a minute. Diagonal 1 times diagonal 2 divided by 2. That's your formula for using a rhombus, or for finding the area of a rhombus. Now, here's where sometimes people get confused, okay? Almost looks like a kite, doesn't it? Okay. So if I labeled this as 3, and this as 3, and this as 5, and this as 5, your diagonals would be, your first diagonal would be 3 plus 3. 3 plus 3 would be 6. Your second diagonal would be 5 times 5, which would be 25, okay? 6 times 25 is 150, and we divide that by 2. So your answer would be 75 for the area. Remember, for dealing with area, it's going to be squared. And let's say that this was centimeters. I didn't give you a, it would be centimeters squared, okay? But I want to point out, make sure that you're including the whole diagonal, 3 and 3 and 5 and 5, okay? It's very important. Otherwise, you will mess that up. You won't get the right answer, okay? Those are just some things I've noticed where some students get a little bit mixed up, and you will have a rhombus on the test, and you will have a triangle on the test. You will have to know how to do the volume of a cone, a cylinder, and a pyramid. You'll have to also know how to do the area of all the shapes, the circle, the trapezoid, the parallelogram, the rectangle, the square. See, am I leaving a triangle? Am I leaving anything out? The rhombus. You have to know how to do the area of all of those. And like I said, you'll have a couple compound area problems. Be sure you understand how to calculate the difference. If you have a square and you have part of it shaded in, let's say you had something like this, and all of this was shaded in, and I want you to tell me what the area of the shaded in portion is. So what you would need to do is you need to find the area of the whole thing, then find the area of the small square within it, and subtract the small square from the whole thing to figure out what this is. So let's talk that again. You would find the area of the whole entire thing. You'd find the area of the center square. To find out just what this is, you would subtract the center square from the area of the whole thing, okay? So hopefully that will help you when you're doing your quizzes. If you have any questions, please feel free to contact me, and I look forward to seeing you next week. I'm gonna step off the screen while I turn this video off, and I will see you next week. Bye-bye.